Alright, number 13. Let me make sure the whole thing is showing. Not seeing the number. Alright, number 13. We have Carlos has a box of coins that he uses when playing poker with his friends. The box currently contains 29 coins, consisting of pennies, dimes, and quarters. The numbers of pennies, so I'm going to write this, pennies equals the number of dimes. So the number of pennies is equal to the number of dimes. So penny, P equals D. So P for penny, D for dimes. And the total value is 179. How many of each denomination does he have? Okay, so they're showing you this kind of breakdown to let you know that a penny is going to be 0.01. I don't know why the amount for dime is missing, but it's going to be 0.1, and then quarter is 0.25, so 25 cents. So we are going to write an expression. The number of pennies, so P, plus the number of dimes, plus the number of quarters, because he has pennies, dimes, and quarters. This is 29 coins. All right. We are given that P equals D, and we also know that a penny is worth 0.01 cents. So 0.01 times P. So the amount that is worth plus 0.1 times D plus 0.25 times Q gives us the value of the money, which is $1.79. Alright, so we were given 3 equations. We have 3 unknowns. So what we're going to do is first substitute P in for D. Alright, so I'm going to put a P here and a P here. So I'm going to have 2 equations, 2 unknowns. So I'm going to have P, and instead of D, I'm going to write plus. Actually, they want to know the number of pennies, which is equal to the number of dimes, is blank. Okay, so we can do that. It's fine. P plus Q equals 29. So this is fine. And then we're going to rewrite this equation. 0.01 P plus 0.1. I'm going to replace D with P again, plus 0.25 Q equals 1.79. Alright, this is a little bit more of an advanced problem. We're going to solve using elimination. We want to eliminate one of these variables. However, I have a problem with these decimals, so I want to convert this expression to whole numbers. So however many decimal places you have, just in each term, just look at one at a time. So this one has 2, this one only has 1, this one has 2. This one also has 2. So the biggest number of decimals in any one particular term is 2. So that means I'm going to multiply by a power of 10 of 2. So when I say a power of 10 times 2, that just gives me 100. So basically, however many decimal places, that's how many zeros you need. You can multiply by 10 to move once, 100 twice, 1,000 3 times, so forth and so on. So just to get this problem to be whole numbers, I'm going to multiply by 100. Try to do this by hand. When I multiply by 100, moves the decimal over 2 times, so it just gives me 1p. When I multiply by 100, moves it over 2 times, so that gives me plus 10p times 100 here, because you're distributing to every term, all of them. This is going to give me plus 25q, and then multiply by 100, moves it over, so that gives me 179. This equation, we're going to combine the 2 p's. So 2p plus q, I'm going to bring that down. 2p plus q equals 29. Combine this equation, so that's going to give us 11p plus 25Q equals 179. Alright, now in order to solve this, we want to eliminate either P or Q so we can find out what's going on. Now I cannot multiply 2 times anything to get 11, and what you do is you look at each of the P's. So if I want to eliminate P, I need these numbers to be the same but have the opposite sign, so when I add them up something cancels out. These are not the same number and they don't have opposite signs, so I'd have to change the numbering sign. And I'll look at Q. This is a 1. I can easily multiply 1 to be 25. I just multiply by 25. Alright, and then if I want it to be the opposite sign, I make it a negative 25. That's going to cancel out Q. It's probably going to be the easiest thing to do, so that's what we're going to do. We're going to multiply this expression by negative 25. And again, where do we get that from? I want to get rid of Q. It's going to be the easiest one to manipulate. I need the same number, which is 25 times 1. And then I need it to be the opposite sign. So that's positive. I need this to be negative. So we're going to distribute negative 25 to each of these terms. So when I do negative 25 times 2, that gives me a negative 50 times P. Negative 25Q gives me a negative 25Q. And then 25 times 29. So we'll compute this with the calculator, pretty big number here. 25 times 29. And it's going to be negative, so I can just make one of them negative. Gives us a negative 725. Alright, once you have them set up like this, we're going to add these two equations together. You might be saying subtract because they're opposite signs. When we do this, we get a negative 39P. This gets eliminated. Alright, and then combining this is going to give us 4, 5, 6. I think that's the way we want to do that. It's going to be a negative. And let's verify that with the calculator just to make sure. We're going to just say plus 179. So I need the bar, I messed that up. So this should be negative 546. Let's check that one more time. 725 minus 179. I know I got it backwards. 546. Okay, we're good to go. Now we have to divide by negative 39. So dividing by negative 39, or since I have it in positive form, just divide by 39. It gives us 14. So that tells us that P, the number of pennies, is equal to 14, and which was also equal to the number of dimes, was 14. Alright, if we add 14 and 14, that gives us 28. And we know that there was 29 coins altogether. So 28 plus Q equals 29. So that means there has to be 1 quarter, because you subtract 28 from both sides. We get Q equals 1. So 1 quarter. Alright. The number of dimes, which is equal to the number of pennies, is 14, and the number of quarters is 1.